Okay, this is part 3 for IR topic. Okay, I missed this one just now. CX or C bonded to halogen is additional depending on the class of compound that are given. Okay, so for CBr, you can see a peak around 650 to 510. Normally peak below 1400 is quite a lot, because most of the bending vibration appear at that region. That's why for additional peak, or additional bonds like CX, is difficult to determine which one is the peak unless you have the molecular formula. So let's say in your molecular formula you have C3H3Br, so you know that there are CBr bond that you need to list down. Okay, so for CI, the frequency is around 600 to 485. You see the range is quite big, so which peak that you want to choose? So again, it depends on the molecular formula. Okay, for IR, the most important or the most difficult part is when you have a carbonyl compounds. Okay, when you have a carbonyl compounds, there are 1, 2, 3, 4, 5, 6, 7 types or 7 classes of compound that has a carbonyl group. Okay, so we have amides, carboxylic acid, ketones, aldehyde, esters, acid chlorides, and anhydride. Okay, when you have a carbonyl compound, first when you look at the spectrum, this carbonyl present around frequency of 1600 to 1800. So that is the range. But that peak belongs to which carbonyl compounds? Normally we have a additional information. Okay, so first look around 1600 to 1800 if there is a very intense peak, because for carbonyl, for C double bond O, the peak is very intense. No way that you can miss that peak. But for each class of carbonyl compound, the C double bond O present at different frequency. So this is normally the frequency for carbonyl for amides is lower than 1700, and you see the carboxylic acid, ketones, aldehyde, ester, and some of the carbonyl compound, they have a range that quite similar. So how to know whether you have a carboxylic acid or you have a ketones? Because carboxylic acid is 1710 and sometimes it's appear around 1712. Okay, we need to look at the second information. Okay, the second information I will explain later on. Yeah. Okay, so first you need to know when you have a carbonyl, you need to look at 1600 to 1800 if you are given a spectrum. Okay, so the explanation on why the carbonyl compound for different class of compounds are different, you need to read on this, but I'm not going to explain on this because we are not ask you on why this one is higher than this. For this topic, we only want you to apply the principle of IR when you have a spectrum and when you don't have a spectrum. But why the carbonyl is different for each class of compound, the explanation is here. Okay, so this is for anhydride. So how to know that you have an anhydride? You must see 2 C double bond O, and the region is 17 something and 18 something. So this 2 peak is very intense and no way you can miss the peak. Okay, for acid chloride, if you look at the list, the C double bond O for acid chloride is very high compared to other of carbonyl group, carbonyl compounds. Okay, why? Because we have the Cl is pull electron from the C double bond O, that makes the C double bond O become C triple bond O. Remember, the triple bond is more vibrate in a higher frequency compared to C double bond O. Okay, so this is all the reason why and why. And then same goes to ester. and we have a carboxylic acid there, the formation of dimer. And this one, when we compare aldehyde and ketones, okay, because when you have the R group give electron inductively to the C, so makes the dipole moment or the changes of dipole moment between C double bond O less. That's why when you look at the list, compare the ketones and the aldehyde vibrate at higher frequency compared to the ketones. Okay, and last one, amide. Why C double bond O of amide is very low compared to other carbonyl compound? Because of the resonance effect. So resonance effects makes the C double bond O now become C single bond O. Okay, so that is on why this carbonyl is higher, why this carbonyl absorb F frequency lower than others. So this is all the explanation. But again, we not ask you on why this one is higher, why this one is lower. But we test you on how to use the IR to determine the functional group present in the molecule. Okay, let's go one by one. If we have the aldehyde, okay, aldehyde, this is the range frequency of the C double bond O. Okay, so what does it mean by this? Conjugation moves the absorption to a lower frequency. Okay, so this is the explanation. When you have an aldehyde, the normal aldehyde, so the frequency of normal aldehyde is 1740 to 1720. But when you have a conjugation, what does it mean by conjugation? The double bond, single bond, double bond is alternate. So this is the conjugation. Conjugation makes the C double bond O, the frequency of this C double bond O lower. So why is it lower? C double bond O now becomes C single bond O. So when you have a compound, okay, let's say this one, 2-butanol, double bond, single bond, double bond. That is the conjugation. The frequency now is become 1690. Okay, so normally is around 1710 or 1725. Sorry, 1725 for aldehyde. When you have a conjugation, it's normally less 30 or 25 cm-1 from the normal one. Normal one is the one that you get from the correlation chart. Anything that has the conjugation is not stated in the correlation chart, but you know that, oh, why the carbonyl is lower? Why is the frequency of the carbonyl is lower? So this is due to the resonance. Resonance means you have a conjugation. Conjugation means you have the double bond, single bond, double bond, alternate. Conjugation makes the C double bond O frequency lower, and this happens to all carbonyl compounds. So it means not only for the aldehyde but also for carboxylic acid, ester, and so on. Okay, so second example is for the ketones. Okay, so look at the ketones. Normally the frequency is 1710, but the conjugation make it less than normal frequency, which is now 1685. Same goes to carboxylic acid. Okay, normal frequency for carboxylic acid is 1710, but you have a conjugation here from the benzene ring. So now the frequency of C double bond O become 1687. Okay, so conjugation lower the frequency of the carbonyl group. Okay, next one, look at the ketone. Okay, before I forgot to explain more. Okay, when you have an aldehyde, okay, let's say I have a simple aldehyde here. Okay, what are the bonds present in this molecule? First, you must have the C double bond O aldehyde. Okay, C double bond O aldehyde. Okay, you need to look at the frequency from the correlation chart. Next one, the most important is CH aldehyde. Okay, CH aldehyde is different from CHsP2, CHsP3, and CHsP. Look at the correlation chart, you will see the CH aldehyde. So remember, CH aldehyde from the spectrum, you see two peaks. which is around 2,700 and 2,800. Remember the word N. From the last slide, when you have C double bond C aromatic, the frequency is 1,600 and 1,400 something. So this is the second item, or the second bonds that you need to put the word N. For CH aldehyde, normally when you look at the spectrum, look back to the list of functional group spectrum that I asked you to practice on. Look at the structure of aldehyde. So you can see 2,700 and 2,800, not exactly 2,800, sometimes 2,840, something like that. That belongs to CH aldehyde. With regards that you see the C double bond O from the spectrum. Okay, so you must see CH aldehyde. And what is the frequency? And then from this structure, you see the CH-sp3. So for aldehyde, so this is all the compound that the list of bond that you can see. If you have a conjugation, okay, for this structure, 2-butanol. What are the bonds present in the molecule? So you have C double bond O, you have CH aldehyde, you have C double bond C alkene, and you have CH alkene, and you have CH alkene, or CH-sp3. CH alkene is CH-sp2. See, when you have additional bonds from your structure, you need to list down everything. Okay, so when you see C double bond O, you need to look at the frequency. This C double bond O belongs to which carbonyl compounds, and the next thing is to see any additional information that can help you to determine the class of the compound. So for aldehyde, it's very easy. No other compound has CH aldehyde at 2,700 and 2,800. Okay, so that is for aldehyde.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.